Good morning, students. The next factor which affect the rate of the chemical reaction which we are going to read is the temperature. So concentrate yourself. Some technicalities, some concepts will be applied. So concentrate yourself. We are going to start. Why do you think food is stored in a refrigerator? The simple answer is on cooling, the rate of the chemical reaction becomes slower. So this is the reason food can be preserved in the refrigerator for a longer time. So the reason is the rate of the decay is slower at lower temperature. Increasing temperature increases the speed of the reaction at higher temperature. So these are things which happen at higher temperature. Reacting particles have more kinetic energy to move around faster and more vigorously. More collisions per unit time produces a higher frequency of the effective collisions per unit time. Hence, the speed of the reaction increases, and more collisions are because of the more kinetic energy. When they move faster, they collide with each other more fastly. More reacting particles have enough energy to overcome the activation energy of the reaction. So this is another point. When temperature is increased, the energy of the particle increases. So more particles are able to overcome the activation energy. Hence, the speed of the reaction increases because you have learned it, you have read it that for a successful reaction, two conditions are necessary. Number one, to overcome the activation energy, that is like a barrier which you have to overcome. And number two, the proper orientation should be there. So, because of the increasing of the temperature, the particles will have enough energy, will have more energy to overcome the activation energy. So, more particles will be able to overcome the activation energy. So, there will be more successful collision, which will result in more formation of the product. So reaction will be completed more quickly. Here is a simple example to illustrate the concept. Reaction at 30 degrees C and reaction at 40 degrees C. Here in 30 degrees C, you can see the number of the collisions are less. Like here is the collision, here is the collision. But at 40 degrees C, the number of the collision increases. So this is the simple thing due to which the rate of the chemical reaction increases. Here is a video that will make your concepts more clear.
Effect of temperature on rate of reaction. Let us study the reaction of oxalic acid with potassium permanganate in the present.
So here we are going to read an experiment of oxalic acid and potassium permanganate. We are going to discuss the effect of the temperature on this reaction. So look now.
Presence of sulfuric acid. Let us study the reaction of oxalic acid with potassium permanganate in the presence of sulfuric acid. Take 0.5 gram of oxalic acid in a beaker and dissolve it in 20 milliliters of water. Now to this oxalic acid solution, add 5 milliliters.
So look now, 0.5 grams of the oxalic acid is taken into the beaker and 100 ml water measured with burette put into the beaker.
Of dilute sulfuric acid.
Here 5 ml of H2SO4 is going to put into the beaker.
To this mixture, add a few drops of potassium permanganate solution.
So 2 to 3
Observe that the
drops.
solution turns pink.
2 to 3 drops are put into the beaker, and the
Now
mixture
stir the solution with a glass.
mixture will become pink. Stir the solution with the help of a glass rod. So time will be taken.
Rod for a while. Observe the color of the solution. The solution remains pink.
So the technique here is potassium permanganate's effect is to color the solution pink. So when the pink solution will be disappeared, the whole reaction will be completed. So actually pink color is the original thing that will show us the completion or incomplete process of the reaction. So when the pink color will be disappeared, reaction will be completed. So we will note the time when pink color will be disappeared. Same reaction, same experiment will be repeated with the same quantities of the reactants, but temperature change on high temperature. At high temperature, you will see the pink color of the solution will be disappeared in less time. So it means the temperature affect the rate of the reaction. At high temperature, the reaction speed is increased. At low temperature, the reaction speed is lesser. So this is the original idea around which the whole story will revolve.
Then, in another beaker, prepare oxalic acid solution in the same way as
So look now, the quantities are same of the reactants.
prepared earlier. Add the same amount of dilute sulfuric acid to it. Now heat the solution.
Now look, all the conditions are same except temperature. Now in this experiment, you are going to heat the mixture. So when the temperature will be increased, the rate of the reaction will be increased and pink color will be disappeared in lesser time.
To about 60 to 80 degrees Celsius and then add a few.
So look now, the temperature is raised up to 60 to 80 degree temperature. When the temperature comes at 60 to 80 degrees C, then potassium permanganate's drops will be added to check the pink color disappeared in lesser time.
Drops of potassium permanganate solution to it. You will observe that on stirring, the pink color of the solution disappears. As the pink color of potassium permanganate does not disappear.
So look now, the difference in the two experiments having the same conditions except temperature. At high temperature, the pink color disappears quite fast in the hot solution. Heating speed up the reaction between oxalic acid and potassium permanganate, whereas when the temperature was lesser, the pink color of the potassium permanganate does not disappear in the cold oxalic sulfuric acid mixture. So this is the difference.
In the cold oxalic acid sulfuric acid mixture, but disappears quite fast in the hot solution. It can be said that heating speeds up the reaction between oxalic acid and potassium permanganate.
So we have checked through an experiment that temperature affect the speed of the reaction. At high temperature, the speed of the reaction increases. At low temperature, the speed of the reaction is lesser. So moving further, the reaction between the sodium thiosulfate and hydrochloric acid can also be used to study the effect of the temperature on the rate of the reaction. So this is the reaction Na2S2O3, that is sodium thiosulfate. ACl is reacting with it and making some products. Here is the product that is under question. So sulfur, which will be produced, will actually make the solution cloudy. And when the solution will become cloudy, we cannot see through the solution then. So look now further. This sulfur forms a precipitate which clouds the solution, and the speed at which this cloudiness appears can be used as a measure of the rate of the reaction. An investigation takes place in the following way. A flask containing the reactants is placed over a piece of the paper with a cross on it. So look now, we will place a cross on a piece of paper and paper will be put on the table. Then a flask will be put over it, and into the flask sodium thiosulfate and ACl will be put. After some time sulfur will be produced. The solution will become cloudy, and we cannot see the mark on the paper because of the cloudiness of the solution. The time will be recorded when this happen, and then the temperature of the solution will be increased. Same thing will be repeated by applying the same quantities of the reactants, only temperature change. You will see the solution will become cloudy in lesser time, and this shows the reaction is completed in lesser time. So this is the story. Look now, a flask containing the reactant is placed over a piece of the paper with a cross on it. The reactants are viewed from the top of the flask, and a stop clock is started when the sulfur precipitate clouds the solution so much that the cross cannot be seen. The stop clock is stopped and the time is recorded. So like this will be the apparatus. A person is looking from above onto the mark, and the time will be recorded when he will not be able to see the mark because of the cloudiness of the solution. The time will be recorded. Look now, the same experiment, if the experiment is repeated several times with the reactant at increasing high temperature, a table of the data can be produced as table shown. So look now, we will repeat this experiment a number of times with same quantities. So look now, sodium thiosulfate and ACl quantities are same, only the temperature is changing. In the beginning temperature was 30 degree, then raising to 35, then 40, then 45, then 60. So only temperature is changed, quantities of the reactants will be same. So when the temperature was 30 degrees C, the time taken for the solution to become cloudy and to become the mark obscured time will be 80 degrees C, 80 seconds. And at 35 degrees C, lesser time will be taken, at 40 even less, and up to so on. And this, so these two sets of the values will be plotted on the sheet of the graph paper. So look now, here is a graph paper produced, and from the graph paper it can be clearly seen that when the temperature was 60 degrees C, the time taken to for the solution to become cloudy was 20 seconds. At 35 degrees C, the time was almost 38 seconds, and at 35 degrees C, the temperature, the time taken was almost 63.4 seconds, and at 25 or 24 degrees C, the time taken was almost 130 seconds. So you can see the process complete, the reaction completed in lesser time when the temperature was higher, and the time taken was more when the temperature was lesser. So this is the inverse relation between the temperature and the time. More the temperature, lesser will be the time. Less the temperature, more will be the time. So this is the effect of temperature on the rate of reaction. And now the observation which can be made from this experiment are, you can see from the graph that the rate of the reaction is fastest at high temperatures. When the temperature at which the reaction is carried out is increased, the energy that the particles have also increases. The particles move faster. This has the result of increasing the number of collision of the sodium thiosulfate and hydrochloric acid particles, and the collision which occur are more energetic and so more likely to form products. Therefore, if the temperature at which a reaction takes place is increased, then the rate of the reaction will be increased. So this was the topic.